I am going to install new evaporator cooling coils in this leaked refrigerator. I will install the evaporator in both the freezer and the fridge compartments. First, I will measure the freezer evaporator to bring the same size new evaporator coil. I am measuring the freezer coil from this point. I can also measure it from 1 inch backward. But I am measuring it from here. Measuring the freezer coil with this radius is very important. Then move the hand further upward. Now I have made it to the upper radius of the freezer. I will put my hand here. And a 45-inch evaporator cooling coil will be installed in this refrigerator. In the same way, I will measure its width from this corner to this corner. And I will place the measuring tape till here. It is almost 19 inches in width, but if I see it in millimeters, it is almost 47.5 millimeters. Now both the freezer and the fridge evaporators have arrived. This is the freezer coil size, which is 19 by 45 inches. The size is also given in millimeters as well. The fridge evaporator is 12 by 15 inches, and the size is also in millimeters. The width size I need is approx 47.5 millimeters. But its width is 19 inches. This means the evaporator width is 7 to 8 millimeters bigger. I will cut this much piece. Now see, the coil is fitting fine in the freezer. And it has a play in it, which will benefit us to install the coil with ease. Now I will measure this bend in the freezer coil. I have already marked it to measure this radius. I will also ensure that this hole should be aligned with the hole in the freezer. But when I measure the hole in this evaporator, is present at 30 centimeters. This means we should get the hole at 30 centimeters inside the freezer. But the hole in the freezer is present at 16.5 centimeters. The hole of the new evaporator coil will not be aligned with this hole. The 30 centimeters comes over here. So the hole will align over here, because the new evaporator is different than this one. Now let's measure the coil till the radius of the bend. Its measurement is 34.5 centimeters till where we marked. Now I will mark the evaporator to 34.5 centimeters.
34.5.
Now I will measure the distance between this bent radius towards the upper bent radius. I also marked the upper bent for measuring it. Its measurement is 44.5 centimeters. I will mark it to 44.5 centimeters. Now I am measuring the rest of the evaporator size. It is 35 centimeters. I have measured it to check that after giving the evaporator a bent, how much the evaporator will left, so it seems like we will have no issue. Now I will have to find what is the radius of the bent. This rounded plastic box is perfect with the radius of the bend. You can see it is accurate with the bend size of the evaporator. It means I will use this plastic box size to bend the evaporator. I will get the perfect radius and the bend for the new evaporator. Now let's check the radius size of this box. I am using the vernier caliper to measure it. The box radius is 67 millimeters. Now I will half the size of the box radius. The bent radius for the evaporator is 33.5 millimeters. Now I will bend this evaporator. For bending it, I will use this pipe. Its radius is the same as what I had told you. I will make a DIY vise to bend the evaporator. You can see I have put masking tape on the iron pipe. I did this to align the center of this point of the iron pipe with the marked evaporator to bend it in accurate size. Now I have made a very simple vise for bending the evaporator. I am moving the vise upward and downward easily. I have cleaned the table beneath the vise to make the bend. I will bend this side of the evaporator plate. Because it has 3 pipes, bending this side after bending the other side will be difficult. I have made this pipe out so it doesn't bother me while bending. These 3 pipes will stay here. Now I will put the evaporator inside the vise from this side, as our bend will be made on the front side. Now I have tightened the bolts of the vise. But still, it is a little loose. I will tighten it as much to prevent the coil pipes from damaging. Now I will measure the evaporator's required size, which is 32 centimeters, and it is 32 centimeters from the other side as well, when I will bend this side of the evaporator. These pipes are on the bottom side of the evaporator. We will not bend these pipes, they will remain the same. The evaporator has been bent perfectly in the center of the marked line. The bent of the pipes are also good. The bent radius is also perfect. The required size for the evaporator was 35 centimeters. It is 35 centimeters from here, and the other corner of the evaporator is also 35 centimeters. I will check the radius through the plastic box. It is perfectly aligned with the box. I said before to align the marking with the masking tape. But that way, size was coming differently. Now I have placed the evaporator out from the vise to make the bend according to my required size. Now let's check this size, which was 44.5 centimeters. It is approx 44.2 centimeters. We can adjust the evaporator while fitting it in the freezer. The next is to take measurements of these pipes. I have already written the measurement of each pipe. From this corner till here, 20 centimeters, 22.3 centimeters, and 24.5 centimeters is its distance. For making a hole in the pipes, I will measure the hole distances from the right side of the evaporator. So I have marked the distance for the hole from the right side. Now I will make the hole in the freezer. Use a 2 to 3 millimeters bigger drill bit than the size of the pipe to make the pipes pass through the drilled hole easily. I am trying to drill a hole in the top corner. Now I am having an issue. This cooling coil is not fitting inside. You can see the evaporator corners touching the body of the refrigerator. Now what is the reason for the evaporator not moving further in the freezer? I will tell you that. But first, you can see these 2 markings on the refrigerator. I already did it. Also, on the left side, I also did a marking on the top corner, which is not visible right now. I will also mark the evaporator as I did on the refrigerator corners. Let me tell you the reason why the evaporator is not moving further inside the refrigerator is due to these shelf holders. On this side as well. Now I will set the evaporator accordingly. While fitting the evaporator in the freezer, I am having problems. But I am solving it as well. But I am not shooting those parts as it will make the video unnecessarily longer. I will have to cut the evaporator according to my need. I have cut this piece from here according to my need. You will try to install in your refrigerator, do the setting of the evaporator according to your need to fit it in the freezer. Now to install the evaporator cooling coil of the fridge, I will find the center of the compartment. I have already marked the center point. I will take the size of these two pipes and also measure the distance between them. This is how the center of the evaporator plate will be located. The center of these pipe is 4 centimeters. I have also marked the size of the hole. Now I will drill holes in the evaporator to fit the defrost heater at the back of the evaporator. Now I will make you understand the connections of the pipes. The capillary opens up over here in this pipe. The pipe, after turning around, moves here. Then it moves downward. 2 pipes are moving downward. Then the pipes, after turning around in the downward section of the evaporator, move upward. They are joined together over here. And see, this pipe is moving upward and moving forward with this pipe. This pipe of the freezer coil will be attached to the right side pipe of the fridge evaporator. The refrigerant will flow through this evaporator. This pipe will be the return pipe of the fridge evaporator, which will be attached to the freezer coil pipe in the center. The pipe is then again moving in the freezer evaporator, which is coming over here. The evaporator pipe then moves through this section, where it will get cooled. Then the pipe moves upwards and is attached to this pipe of the evaporator. Then this pipe is the return pipe, which from the back side is this pipe, which will be made as the return pipe for the compressor. Now I have properly brazed both the evaporator pipes together and covered them. The next is to fit the condenser. I will have to give a gap over here to install the condenser. The refrigerator is ready to be vacuumed and to be charged with refrigerant. I will turn on the vacuum pump to vacuum the air out of the system. The system has been vacuumed. The needle is at -30 on the manifold. I will turn off the valve of the manifold and then turn off the vacuum pump. I have placed the refrigerant cylinder of R134A on the weight scale. The weight of the cylinder is 5.960 kilograms. When we measure the weight of the cylinder with the hose pipe attached, it shows a different weight. That's why I measured it first. Now I will open the valve of the cylinder. I will purge the hose I installed with the cylinder. The air has got out of the hose. Now I have placed it on the weight machine, and let's check the weight of the cylinder. Now it is showing 6 kilograms weight of the cylinder. I will crack the vacuum by opening the valves of the manifold. I will charge 30 to 40 grams of refrigerant in the refrigerator. Now I will wait for a while before turning on the refrigerator because the liquid is also gone inside the system. Now the refrigerant charging in the refrigerator is completed. I have charged almost 210 grams of refrigerant in this refrigerator. I have also turned on the refrigerator. The refrigerator is consuming 1.3 amps and is cooling extremely well. Before showing you the cooling coils, I will lock the refrigerant. Now I will braise this pipe but will turn off the refrigerator before doing it. Braising the pipe will make it look like original. The temperature of the freezer right now is minus 17 degrees. Let me open the freezer door to check it. The freezer is cooling extremely well. I can feel it by touching the cooling coil with my hands. The same is on the lower compartment. It has been cooled. The ice is present on this evaporator as well. Click on the left or right thumbnail to watch our next videos. And subscribe. It's free. Thank you.